We're going to talk about analyzing OT radio implementations, and we're going to be talking about the attack infrastructure, excuse me, the attack surface of those and how they apply to your processes. Go ahead and next slide, sir. First of all, a little bit about me. I am a SANS instructor, so I teach the ICS410, which is the ICS SCADA Security Essentials class. And I also teach the hosted class that's titled Assessing and Exploiting Control Systems. And both classes talk about the basics of the OT environment, the ICS environments, helping people understand what's going on within these from an information security perspective, bringing the teams together, the OT and the IT security teams together so that they're operating off of the same concepts, the same technologies, terminologies, and so forth. And I really enjoy that. And thanks, Rob. So part of what I wanted to do in this talk would not have been possible if it hadn't been for the ICS410 class and some of the things that I'm able to do with them. You know, we're progressing that to the ICS612 and certainly considering some penetration testing courses to extend that as well. This program, the ICS program at SANS, is really helping me expand some of that research and so forth. But definitely, this wouldn't have been possible without the ICS Village and the support from them providing me with some equipment and some considerations around that. So I wanted to say thank you to them. Next slide, Rob. But because of that, because I do have some equipment, because I am going to be pointing to some specifics, leveraging information from certain products, so you might recognize some of the products, some people might not. I just want to make it very, very clear that nothing in this presentation is going to be talking about vulnerabilities in those implementations. Okay, so the vendor products, typically when you get these products from vendors that are implementing this out in your control systems, out in your control networks, they provide very specific instructions on how to do this securely. You just need to read the documents. And so I highly recommend you do that before, so that you have your requirements before your implementation. And we're going to talk about some of the reasons why you want to do that. But there's no vulnerabilities in any of the technologies that I'm pointing to right now. At least I'm not going to point any out within this presentation. All right, so why are we here? Well, we have processes out there that have wireless within them. And we're not just talking about Wi-Fi, and certainly Wi-Fi is a consideration. But I wanted to talk about radio, because Wi-Fi, you know, you can do it poorly, and you do need to do security assessments on that. But the radio gateways, the radio endpoints are actually the closest things to some of our processes. And we have those endpoints, we're deploying those endpoints out there to first provide us a vision into that, but then also to provide some control as well. And it really depends on the implementation, how the process needs it, how the vendors and the integrators have deployed it within our environments. And we need to understand how to do it securely, because those radios will receive anything that is transmitted near or around it. And that's a part of the problem that we need to understand and then address with some of our requirements. Next slide. Within the ICS410 class, we teach that there are 3 internal truths about wireless security. The first one is that denial of service can't be stopped. It's easy to do. If somebody wants to do a denial of service, there are multiple ways to approach it, whether it's physical, or whether it's through jamming, whether it's through disassociation. And it's almost impossible to defend against that, because you don't know when they're going to transmit. The radios are going to accept the transmission. So that has to be a consideration in your head. Network capture as well. This is a public network. You are transmitting to across a medium that is accessible to everybody. And so regardless of the implementation and how it's implemented, people are going to be able to capture it. It might need special equipment, but you can purchase that, whether it's from vendors, whether it's off eBay. You can get the equipment that can communicate, that can capture that traffic, and it can get relatively cheap. And we'll talk about that a little bit cost a little bit later. And then finally, all of these radios have accept communications from anywhere, and that provides the attackers the capabilities to communicate with these endpoints and potentially have a negative impact on them. Okay, so that was our biggest concern. And this, you know, I say +1 in the title of this slide, and that's because when I was getting a peer review for this, I try to get it peer reviewed by the people that are supporting the SANS class. As you can see, Tim Conway wanted me to point out one thing very specifically here. It's like, of course, these things are the eternal truths. These things that are the things that we need to consider within our process. But anybody implementing wireless needs to also consider this one, which is if you're implementing wireless within your process, you need to ensure that you have determined whether or not that process can run without the communications that those radios are providing. And I think that was, I couldn't pick a better slide to put this in, because that, in my mind, is another eternal truth. We need to make sure that our processes are resilient when these communications are not available. So thank you, Tim. All right, I started down this path when I first got into it. I started working with Matt Carpenter and Andrew Ryder, and we started looking at the radio systems that were being implemented within the utility industry, specifically within the smart meter arena. And a lot of the vendors that were implementing these technologies were leveraging frequency hopping for the exchange of information. And a lot of them considered frequency hopping to be a secure and almost impossible method of exchange of information to attack, okay? And that's when we kind of took on the challenge to start looking at it, all right? As you can see in the image right here, we have, this gives you an example of what frequency hopping is, and that's transmissions on different channels at different times. It helps with certain things. It prevents transmission collisions. It also prevents interference and jamming. And you can see that if I'm on a different channel at different times, then it's going to be hard to stop that information. It's going to be hard to jam that information. And a lot of vendors considered this actually, and they told us to our faces that they consider this a form of encryption. But if you look really, really hard at that image right there, you can see that there's a pattern. You can see that there are windows, time slots, that those sequences repeat. And so people like myself, people that are attacking, or I'm not an attacker, I'm a security researcher. So when I'm trying to understand this, I look at that. But attackers are looking at the same things. They're taking that in consideration. Not only can I predict the pattern there, but why? I can just eavesdrop on any single one of those channels and I can get the information. And actually, I can inject information on any one of those channels. I can just find out what the center frequency for any one of those specific hops are and transmit anything I want. And I know very specifically that there have been cases of vulnerabilities that have been found in security research through source code analysis that have been successfully injected to have a negative impact on the endpoint device and bring that, that device down. So it's possible that no matter what your frequency hopping pattern is, no matter what you're doing, how you're implementing your frequency hopping, it's subject to eavesdropping, it's subject to injection. And unfortunately, what frequency hopping does in a lot of cases, that when people don't understand these things, is it leads to a false sense of security, okay? Rob, next slide, sir. So in the ICS410 class, these are the 4 things that we teach as the attack surface for our wireless networks. We've talked about eavesdropping already, which is the capturing of data. We've talked a little bit about masquerading as well. And what masquerading is when you're pretending to be one of the endpoints on that wireless network, whether it's the gateway, the master radio. You can consider that as an access point, and in Wi-Fi, you would call it an actual access point. Then you have your endpoint devices, which might be the endpoints on your process. Okay, masquerading would be mimicking any one of those and transmitting information as that endpoint to the other endpoints. Okay, denial of service. Denial of service is just blocking the traffic, and we've talked about just jamming, which is just straight up putting signal out there so that there's too much interference on a specific bandwidth of radio frequency, whether it's a large bandwidth or whether it's very specific to hops. But there's also disassociation attacks where we understand how the endpoints are communicating and we leverage the specifics of that protocol to cause those endpoints to shut down or not talk to other endpoints. And so that's another type of denial of service. And then finally, we have rogue access points. We have rogue devices that are within our networks. This is more common for our Wi-Fi networks when we're talking about rogue access or rogue wireless access points. It can be a consideration for radio networks, but it's not as typical outside of the Wi-Fi arena. Rob? So taking that attack surface, now we can start building an attack tree. What are the ways that people are going to try to leverage those things against our devices? And there on the left, we can see the gateway and the field devices. The next block over, we see denial of service, masquerade, and rogue devices. So those are going to be our attack surface. As you can see in this, I have rogue device X'd out. And that's because, while I'm more concerned about that in a Wi-Fi arena, I'm not necessarily concerned about that in a wireless arena. So I'm going to focus on, and we're going to be talking about denial of service and masquerading. So when we're thinking about denial of service, we can break those attacks down to jamming, which is just straight up just transmitting on a frequency and ensuring that things can't communicate within that frequency. And then disassociation, as I mentioned, leveraging the protocol against itself to keep things from communicating within that network. Now, when we're thinking about masquerading, we have to think about two forms of attack. We have injection and replay. Injection is just going to be, well, let's start with replay. Replay is probably a little bit easier. Replay means that I'm capturing some traffic, I'm capturing a transmission, and I don't even need to understand what's in that transmission, okay? I just resend it. Does the endpoint accept it, okay? When we're thinking about replay attacks, we do, or we should be, if we want to consider what's going on with that, we should consider whether or not the packets are encrypted or unencrypted. If they're encrypted, I'm just going to try to resend those, okay, and see if the other endpoint accepts it and either redoes that action or takes some action associated with that packet. It's going to at least process it. My expectation would be that it would reject it, but certainly that's the testing that needs to be done. For unencrypted packets, if I can tell that they're unencrypted, for the replay, I might just send, but I might need to make some modifications depending on the protocol. I might need to increment some fields. And so I would use that I would make those updates, but still consider that a replay attack. For our injection, I also want to consider the same things, unencrypted packets and encrypted packets. For the encrypted packets, I might need to see whether or not I can re-encrypt a packet myself. If I know how the radio or the processor is encrypting that information, if I can pull the certificates or the keys that are used to encrypt packets, then I'm going to want to do that to any packets that I want to send. I want to encrypt those. And so that's a little bit more of a complex attack, but it's certainly doable because there are vendors out there that implement things in a way that are not resilient to the extraction of that information. And if I can extract that information, then I can leverage that to re-encrypt to encrypt my own packets, and then hopefully send that on the network so that the endpoints process that information. And then, of course, we're really concerned about unencrypted packets. If I understand that the network is unencrypted, then I can start building my own packets. I can start injecting my own information into the devices, and hopefully, if whatever my goal is, try to accomplish my goal. Rob? So most of the wireless solutions, the radio solutions that we're talking about, most of the vendors that I've seen, at least some of the larger vendors that are implementing this, they have taken into consideration the fact that frequency hopping does not protect the packets. Myself, Matt, and Andrew, we gave a talk at ShmooCon back in 2011, I believe. It was called Hack Hopping Hetty, or Hop Hacking Hetty. And basically what it was just demonstrating that there are techniques to go after the frequency hopping, there are techniques to inject and so forth. And that's when we started seeing the vendors, because we put that research out there, because we made it public and we started talking about it, and the customers started raising concerns. The vendors started implementing and recognizing that these attacks are possible, and started implementing encryption within their technologies. And that's a great thing, and that's what we wanted the whole time. Unfortunately, the vendors cannot predict how their customers are going to implement these networks. As you saw on the first slide where I talked about the radios, there's all kinds of different methods for implementing. There's mesh networking, there's star topology, there's point-to-point. They don't know how you're going to implement things. And doing encryption within each one of those methods takes some special configuration. So it is up to the implementers, it is up to the customers to turn on that encryption. And as you can see, encryption is turned off by default for most of the vendors. All right, so that's why I'm here. That's why I wanted to talk about this and let you know that those requirements, you need to consider this when you're thinking about the requirements around implementing wireless within your environment. Next slide, sir. So what are the costs of doing some of these attacks? Well, right in the middle there, we see a lot of different technologies. We see radios, we see spectrum analyzers, software-defined radios, which are software, and also hardware radio software that it was developed by the community. The majority of, all of the software that I have listed down there in the bottom 3 bullets, those are free. You can download those for free. They're open source projects. There are some vendor development kits. There are some vendor softwares to interact with their network that do cost, and you have to be a customer for that vendor. But when you can't get access to those, you can fall back to a lot of the radio research that's been performed by security experts, have been performed by high school and university students around this area. The radios that you see there are relatively cheap radios. You can get some expensive radios. Actually, the Edis radios are probably, that I have listed there in the 3rd bullet, are probably the most expensive, but they're very, very accurate. And, they're the things that we like to use when we want to definitely, be very specific about our research. But as you can see from the images, that I can do capture for as little as $30. I can do captures with, outside of your buildings and your networks. I may or may not be successful, but the closer I get, the better it's going to be. The better antenna I have, the further I can stand off. The better equipment I have, the further I can stand off. But I can start for as little as $30. I can take that thought process, and as you can see on the bottom 2 images, I can, for as little as $120 per channel, jam or interfere with all of your channels within your hopping pattern. Okay, so I can just see what your offsets are, buy as many radios as it takes to do that, and implement jamming. If I've able to figure out your hopping pattern through observation or through some type of hardware manipulation, I can program a device. And the example here is the Yardstick 1. I can reprogram, I can reflash that firmware, and I can jam all of your hopping pattern for as little as $120. And then finally, in the upper right-hand corner, we can see the injection and replay. I use the Yardstick again, only $120, but it works on a lot of 900 megahertz radios. Okay, so these are the tools that I fall back to. Next slide, sir. So when I was doing this, I told you that I had Tim, do a peer review for me. He's like, yeah, Don, but what about industrial wireless? I was like, oh, you're absolutely right, Tim. Industrial wireless. I need to talk about wireless HART. I need to talk about ISA 100. Those are the 2 biggest industrial protocols that are implemented within the wireless space within out there in the industry. Okay, these are technologies that are based on IEEE 802.15.4 technologies. For those of you that are not familiar with those but are familiar with Zigbee, it's a very similar to the base. Base protocol is the same that is based off of Zigbee. And that's significant because we have a lot of security research that is around Zigbee technologies, because the smart grid industry was leaning towards that pretty heavily for some of the consumer home automation communications with the smart meters. And the Killer Bee project, started by Josh Wright and carried on by some excellent open source teams. That Killer Bee project not only is useful for the Zigbee arena, but has been, and I provide 2 links in here where people have been leveraging that toolkit to do assessments and actually to attack wireless HART and ISA 100 networks. And that's the problem about this, however, is that that research is from 2017. In other words, the security researchers, they're either doing their own projects, doing different projects, or have kind of pulled back their information sharing around that because of a client or something like that. In other words, the public isn't getting the updated tools to do assessments on these wireless networks. And that's a problem because the attackers, they don't share this information. And certainly if this is one of their goals, if this is one of the ways that they want to attack your network, they are proceeding with their research. They are sharing their tools internally. And we just don't know what their progress is. And so that's actually one of my concerns. It's why I want to see progress within this type of research as well. Next slide, sir. So for many of the companies that are going to be implementing these technologies, most of them are not going to be associated with critical infrastructure. And when I'm considering those environments, I do want them to be considering correct requirements for implementation, but they probably don't need to do some of the deep dives into the actual implementations by the vendors. And what I mean by that is, actually tearing apart the devices, looking at the microcontrollers, looking at the radios, how they're storing information, how they're storing keys and certificates for encryption and so forth. So, our industries like food and beverage, some of our distributions, I encourage them to ensure that they're correctly implementing these technologies. That's their biggest risk around that. But when I start thinking about critical infrastructure, when I start thinking about the people that have security programs and that have implemented this, turned on the encryption within these networks, they need to start thinking about how did the vendors actually develop and implement these technologies, because this is how the attackers are going to learn. That's what I do as a security researcher. I start looking at these devices, start pulling them apart, seeing if I can understand frequency hopping by pulling the information from the microcontrollers, seeing if I can understand if they have certificates stored insecurely, and even trying to determine whether or not I can predict their certificates. If there are cases where vendors have picked 10 certificates, as an example, deployed it to all their devices, and then pushed it out. And there's no way for vendors or for customers to update those certificates, but all of a sudden they become public. So understanding that will help everybody understand the risk around implementing some of these technologies and addressing it with the requirements or compensating controls. But we wouldn't understand that without security research into these devices, actually pulling them apart, actually seeing what their implementation is. Next slide, sir. So in conclusion, if you're implementing wireless within your processes, you need to understand what your process can do. You need to ensure that your process can operate without those communications. The wireless networks potentially are going to go down for some reason. and hopefully it's not an attacker, but your process needs to operate without the communication exchange between the endpoints. Okay. You need to outline, you need to review your solutions, especially with your vendors and your implementers, and identify your security requirements before implementation. Okay. You want to ensure that you're turning on encryption before it goes out in the field, rather than having it deployed out in the field with its default configuration, right? You also need to test to verify that implementation as well. You need to ensure that the encryption has been turned on, and that it's configured correctly across all of your infrastructure. You need to ensure that when you have maintenance updates, that they don't roll back to ensure testing and not re-enable all of those encryption mechanisms, because that can happen as well. And then finally, I hope that, like ICS Village, like the SANS ICS team, I hope that all of you will consider supporting research into these technologies, helping people with the tool sets. This is a basic setup that I was provided by the ICS Village to start implementing some testing, just for, not necessarily to identify vulnerabilities within this implementation, but by this vendor, but to understand how to help people identify the requirements and justify the requirements, configuration, all of the extra steps as well. So I'm really, really excited about some of this research, and it wouldn't have been possible without the Village. Next slide, sir. And that's it. My name is Don Weber. Like I said, I'm part of the SANS ICS410 class, so please reach out. You have my contact information there. Thomas Van Norman, who spoke earlier with the ICS Village. If you have any questions about wireless, certainly I'm going to try to move a lot of this research back into the Village, implement it in the Village. It's just going to take us a little time to get everything configured correctly. Other than that, I really appreciate your time. I really appreciate Dragos putting on this event. Thank you very much, sir, for asking me to present.